Okay, in this video, I'm going to show you an example of a problem involving exponential decay. In particular, this is a problem on half-life. Now, to give you the idea about half-life, okay, before we proceed to the actual problem, whenever we use the term half-life, it means it's the time when it's the time when half half of the original amount is present. Okay, so for example, if a certain um, amount or the original amount is about 100, then the half-life means we want to find the time when the amount is already 50. Okay, so note this is an application of exponential decay, so the amount will be decreasing, okay, until it reaches 0 after some time. Okay, now, since exponential decay problems will use the function a, so a of t is equal to initial amount e to the negative kt. So take note, I'm using negative because this is for decay. If it's exponential growth, then the negative sign for decay will not be there. Okay, but the function that we'll be using will be a of t equals a sub 0 e to the negative kt. Now, if we analyze the problem, it is saying that currently the remaining amount is just 1.67% of the original amount. And the original amount that it is talking about is the initial amount. So right now, if a sub 0 is the original amount, then currently the present amount is 0.0167 of a sub 0. This is the present amount. In this case, this is our a, okay, the a value. So if t is the time that has passed until the amount became 0.1 or 0.0167 of the initial amount, then the function that or the equation that we can use is that the present amount 167a sub 0 is equal to the initial amount e to the negative k and then times t. Now if I will divide a sub 0 or the right side by a sub 0, then this becomes 0.0167 equals e to the negative k t. And then if I will take the ln of both sides, then this will become ln of 0.0167 equals negative k times t ln of v. But ln of v is equal to 1, so this is 1. So we have ln of 0.0167 is equal to negative k times t. So the value of t is equal to ln of 0.0167 divided by the negative k. Now, as you can see, we don't have a value for k right now because it did not say how fast is the value decreasing. Okay, we know it is currently 1.67 of the original amount, but it didn't say the rate. Okay, k is basically the rate. We don't know the rate. So this is almost done, except that we need to find the value of k. So how do we find that? So we have to look at more information in the problem. Now, if you notice, there is a statement saying that the half-life of carbon-14 is 5,600 years. So, half-life again is a time when half of the amount is present. So if I will be using that information and I connect that to the function, and that means when half of the initial, so a sub 0, e to the negative k, the time is 5,600 years. Okay? So the t is 5,600. So the t here is 5,600. And I can see that I can actually find the value of k from this equation. Okay? Similar to what we are doing on the left side, the solution that we're doing on the left side. This new equation can be solved in that manner. So I have to divide by a sub 0, so no more a sub 0. So 1/2 is equal to e to the negative k times 5,600, or 5,600 k. Then I'll take ln of both sides. So ln of 1/2, let's make that 0.5, that's 1/2, is equal to negative 5,600 k ln of e. But again, ln of e is equal to 1. So this is negative 5,600 k equals ln of 0.5. So the k will be equal to the ln of 0.5 divided by the negative 5,600, which is the k that we need in the equation to find the value of t. So the t is basically, so t is equal to ln of 0.0167 divided by the negative of k, which is this value, ln of 0.5 over the negative of 5,600. If you will compute for this value, then that will give us the value for the t. Okay? So you need your calculator to do this. This is approximately 33,062. It's 0.44, but this is we want it to be whole numbers, so 33,062 years. So how old is the tree, or when was the tree cut and burned? It was actually 33,062 years ago. Okay? From the present time. So if considering that at present the remaining carbon 14 is 1.67% of the original amount, then that means we have, or it took about 33,062 years for that to happen. Okay? So I hope you understand the solution. I think the finding okay might confuse you, but this will become clearer when you are exposed to similar problems to this. Okay? The key skills that you need to know are, you need to recognize what kind of problem this is. In this case, it's an exponential decay, so you'll be using the a of t equals a sub 0 raised to negative kt, and then put in the numbers or the values that you know. So it's like a of t is 0.0167 of a sub 0, because it says the current amount is just 1.67% of the original amount. So even if we don't know the initial amount, we would we can still represent the current amount in terms of the original amount, which is a sub 0. And then try to manipulate the equation until you get the expression for the t. Now obviously, on this step, we have a missing value for k, so that required us to find the k. So we look for another information in the problem, and we found that there is an information about the half-life of carbon-14. So we did a similar solution to find the value of k by setting up the equation here. And then again, just manipulate the equation until you get the desired value. Now, after getting the k, we went back to the t, and to find the number of years, we simply substituted the value for k in the equation of t. Okay? So that's how you solve half-life problem. So again, if there is something that is confusing, the best advice that I can give you is to watch the video again. But if the things are not yet clear, you can consult me or ask your friends who knows or who know how to solve the problem. Okay? So but first try to watch it again. Maybe you will be able to understand it more the second time around. Okay, that's it.